We are now on air. This is Group 6 from Math221B. We are doing our Lesson 4 meeting. So part 2 is fairly simple. The first 2 questions based on the die. Question 5 is an 8-sided die has 8 possible outcomes for each roll. Calculate the probability of rolling a number greater than 5. So any questions on this? I think it's fairly straightforward.
Pretty easy.
Yeah, super simple.
So I'm assuming we all got 3 out of 8, correct?
Yep.
And then the second one is this, essentially the counter, not a roll greater than 5, which is 5 out of 8. That's just easy math. And one of the things to note about this is the 3 out of 8 and 5 out of 8 make 8 out of 8, which is the probability you should have when you were just not the outcome.
Yeah. Yep.
All right. So let's move on to the group meeting then, or group quiz.
Sounds good.
We might be able to finish in like 10 minutes.
Daddy, it's
Let me know when you guys are on.
Yeah, just give me 1 second.
Lesson 4, right?
Yeah, lesson 4. Lesson 5 will be more difficult. We have an applet and we're talking about actual different maps we have never done before. So this week will probably be 10 minutes. Next week this lesson will be 10 minutes. Probably the one we do on Thursday will be longer.
Yep.
It's all right.
So just like as a general, maybe you guys could fill me in if I miss anything. I think just the big picture here is that probability cannot be bigger than 1. It can't be negative. What else was I looking at there?
The sum of the probability of an event equals 1. So if you have, say, your heads or tails, it's a 50-50. So 1 out of 2 plus 1 out of 2 is 2 out of 2, which is 1. The idea is the number of outcomes, possible events, all add up in the probability to equal the uncertainty of it will happen. And if an event has if the probability event is 1, then it will happen. It's certain. If probability 0, it's impossible.
Right, and then in this class, because I'm taking 2 different math classes right now. Have we done the product and sum rule?
I don't think so yet. That doesn't sound familiar.
Okay. Alrighty then. Okay, so the first couple questions on the quiz are personal.
I have it up here.
hold on.
So give all your answers as decimals and do not give probabilities as percent.
All right. The first question I'll read. The blood types and proportions given in the table above define a probability distribution. So what you're asking for is, do these proportions add up to 1? Is that correct?
Do they?
I believe they do. So 85 plus. Yeah, I think they add up to 100, unless my math's wrong. But that's the definition of probability. All the counts add up to.
Yeah, it's 1.
All right, that I believe it's true then.
Okay. Then 4 says, what is the probability that a randomly selected person in the United States has type O blood, rounded to decimal places? So it'd be 0.45.
Yeah, I think
4 or 5. It gives us the answer.
yeah, I know. Okay, here is 5. What is the probability a randomly selected person will not have type O blood? That's just a counter, so it should be 0.55, right?
1 minus 0.45, yeah, so.
Yeah. 0.55.
Someone want to read the next information thing?
Sure, I can do that.
Okay.
Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs are trained to lie down next to a specimen derived from a bladder cancer patient. Tingle, one of the dogs, demonstrates the identification of a specimen. Seven bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. One of the samples came from a person identified as a bladder cancer patient. The dogs guessed at random. What is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient?
Okay, so the key, I guess, is the guessing has nothing to do with training.
Yeah.
So,
This is random. So it's I think we're talking about the random discrete variable idea. So it's essentially it should be 1 out of 7, correct?
Yeah, so it'd be like 0.143 if you're rounding it.
Yeah, because that's round to 3.
Or we're just rounding it to 2, so probably like 1.4.
It says round answer to 3 decimal places.
Oh, it does. Okay, so 0.143.
Yep, I'm cool with that. All right, I'm going to read the next one. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It's very likely the dog would do this well by random chance alone. Which of the following statements is most appropriate?
I'm so sorry. What did you guys get for the last one? Was it 1.43?
0.143, like
Yeah.
0.143.
Yeah, sorry.
Thank you. Sorry about that.
Very good.
What do you guys think? I mean, 22 out of 54, that's a little less than half.
Yeah,
Yeah,
I mean, it does say that it is very unlikely that the dogs would have done this well by random chance alone.
Well, here's an
I wouldn't
idea.
say there's strong evidence.
Yeah, let me do some quick calculation. You got 54 trials, and you have a 1 out of 7 chance. Help me remember. If you're trying to calculate the probability, if it stays the same at a certain number, would you like 1 out of 7 to the 54?
Wait, what was that?
I'm trying to remember. This is not in the math for this week. I'm just doing something else. I'm thinking if you're 54 trials, you have 1 out of 7 chance. Supposedly, you can do some math to figure out the probability of that. I'm just trying to figure out.
Yeah, I mean, like, well, so what did they get here? So 22 divided by 54 is 0.4. So like 0.407.
Yeah.
So they did a lot better than
Well, just this even
26% better.
Yeah, but I still wouldn't say there's strong evidence. I'd say there's little evidence. Like there is some.
I don't know, because 40% is pretty close to 50. And if you look at the randomized 1 out of 7 for 54 trials, you could just as likely because you could probably just as likely get none of it right as you were to get. I mean, it's 1 out of 7. If you have very terrible luck, you could get all of them wrong. I think 22 could provide. You could make an argument for strong evidence. I would probably put medium evidence, but since strong or little, I'll probably go strong.
Yeah. So like basically, what happened is about 40% of the time they picked the 1 out of 7.
Yeah.
And so that, I guess, from the way you explained it, you're right. That is pretty strong evidence.
That makes sense, Spencer?
Yeah, but what's the parameter in order for it to be strong, or the parameter in order for it to be little? Like, are we looking at a certain number range where it would be little?
I would think.
No, I think just anything above the probability, really. Like, and this is pretty well above the probability.
Because the probability of 1 out of 7 of 54, if you're doing 54 trials, 1 out of 7 chance, it's not a high probability of getting them all right. It's like, I think the probability of getting them all right is more than 10 digits. It's ridiculous. It's e to something. So the idea they got 22, you could at least make a case that there is some factor playing in, because if it was random, I would agree with, like, I would say it's little if they're like 7 or 8, because 54 you could probably get lucky 7 or 8 times. But it's like, imagine you were doing like a pick one number out of 7 for a jackpot thing. You did 54 times. the odds you can jackpot alone are. You get what I'm saying?
Yeah.
Yeah. It makes a lot of sense.
The fact also that it says that it's very unlikely that it would happen by random chance alone. Like
I think that is
the answer.
Yeah. Okay. I think we're good then if it's strong.
Yep.
All right.
Yeah, we can do that. Because we have 2 attempts, right?
Yeah.
So
If it's wrong, it's not that hard to fix. All right. Someone want to read the next thing?
I can do that.
Cool.
M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in a bag of plain M&Ms is given in the following table. We can read that table on our own. If you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy?
Give me 1 second. I'm gonna make sure this adds up to 100.
We don't have green either. That's probably by. We're probably gonna have to do it later.
Yeah, probably just subtract it.
Yeah, it looks like to me, green is. I got one more. All right, green should be 0.16.
Okay, and that's I think the next question.
Okay.
0.16, like
yeah. So like 0.16.
Okay, 0.1.
Because it should all the numbers should add to a 1 or 100%. So if you're taking it as at the points a decimal it is, then you should add up all, and the remaining should be your 1 from subtracted from 1.
Yeah.
In this case, 0.84.
Yeah, that's what I got.
So for 8, it's just 3.
Yeah, they give it to you. It's really simple. The wording gets tricky.
All right, and then question 10. Are we all good to move on to that?
Yep.
All right. So, what is the probability that a randomly selected candy is not green? So basically, what you have to do is 1 subtract
1.6.
You could also just take out the. You could also keep your answer from the previous question where you had to add them all up to find green. That number 0.84.
That's what I did.
Yeah, no, it's actually.
Yep. Easy.
If only the whole semester is like this.
Yeah, I doubt
know,
it.
Right?
All right, I'll read this. The ATC scores of students admitted to a medium-sized public university in the Western United States were taken from capits.com. The following summary statistics were calculated. We can read the table on our own, but we got to figure out. First thing to figure out is how much that total is. So if you guys want to just add up all those statistics.
Well, hold on. No.
Yeah, go ahead.
Because that's just so. This is just a review. It's just showing us the.
Okay, sorry, I read that wrong.
Those aren't the data. Those are just all the separate.
So the answer to this one would be the median.
Yeah, median makes sense.
Okay. So I'd say 24.
Or it would be the half, or okay, yeah, it's median. It's less than or equal to what number of half?
It is median, yeah.
Or would it be mean?
No, because mean's technically not half. It's like
the average. Okay, yeah. Medium is the exact middle spot.
Yeah.
And that just confusing me.
Good call, man. That would have gotten me.
Yeah, it is kind of confusing sometimes. Not that it's that far off. It's 24 and 24.3, but
yeah,
they'll get it wrong. So.
So this question 12, the top 25%, that would be the Q3, correct?
Yeah, that would be Q3. So it says the interquartile range, the IQR is 5. So that means there's about 5 points or 5 numbers in between each quartile.
Okay.
So 24 plus 5, I would assume would be 29. Correct me if anyone thinks I'm wrong, but
well, Q3 isn't it like the middle of that quartile?
Q3 is 75%.
All right.
So that would be, and 24 is 50%. So, okay. And then it says there's 5 numbers in between those numbers. So that's where I'm getting 29.
All right, well, I'm looking at the Q3 here.
Q3 says 27. Wait, what?
Yeah, that's what I'm getting confused.
That's what's not making sense. Okay, that's not making any sense to me.
Well, the question is, does Q3 represent the exact cutoff point, or is it the middle? Because, yeah, that's then, okay.
The top 25% above.
Why didn't you just say they score by 27?
That's what I'm thinking, but the interquartile range,
And maybe that's a different number. Maybe that doesn't mean anything.
yeah, let's just go with 27. I'm comfortable going with Q3 now. Okay, with you guys.
Q3's right, so it should be.
Yeah.
Which of the following statements? I'll read this one. Which of the following statements is not one of the three rules of probability? Probability of one.
That one's correct. The first one.
Probability of the numbers between 0 and 1. That's true.
I think it's the third one.
Yeah, because there can be no negative probability.
Yep.
Does that make sense to everyone?
Yeah, there can't be negative probability.
Perfect.
All right. Let's see how we did.
All right. I'll be the guinea pig.
Watch, we get all of them wrong.
Oh, no.
All right, that was 100 for me. We all get 100.
Let's see if mine's
still low. Yeah,
I got 100, guys.
I think I mixed up number 9, number 10. Oops. Well, number 9 is simple. It's 0.14, right?
0.16 is number 9.
Oh, and then 10, 0.84.
Yeah.
Yes.
Oh, yep. I pretty much got 100.
Well, you can go back and try it again. You should be able to get it correct this time.
Yeah.
All right, we good with this meeting? Are we all good for Tuesday at 2? Or Thursday, sorry. Thursday at 2.
Thursday at 2 works for me.
Sounds good.
All right. I'm going to stop the broadcast. I'll see you guys later. I'll post this up in a sec.
All right. See you guys later.
All right, bye.